ASML provides chip makers with lithography machines that are critical to the production of microchips. These machines project an image of a chip's electronic circuits onto a silicon wafer. For years, lithographers have been shrinking the lines in this image to make more powerful and smaller chips. But as chip makers shrink transistors to atomic sizes, the challenges become enormous.
In chip manufacturing, it's all about smaller features. The key question is, how do we keep the image sharp while it becomes smaller and smaller on the wafer? This is determined by the wavelengths of the light and the optical properties of the lens. Basically, we need shorter wavelengths or new lens materials and designs.
Today, our machines use deep ultraviolet light and quartz lenses, plus water between the lens and the wafer, to enable chip makers to produce semiconductors with features as small as 38 nanometers. Shrinking them any further becomes complicated. However, engineers have discovered a workaround. We have been looking at the solution for centuries. When writing music, notes are placed on what is known as a stave, not only on the lines, but also in the spaces in between. Having more notes and less distance between them enables a fuller and more sophisticated sound. Fitting more lines onto a chip makes them more powerful.
The trick is to expose the wafer twice, imaging half of the integrated circuits in the first exposure and the second half in the second exposure. This is called double patterning. Double patterning is the solution to keep the industry following Moore's law.
One method currently favored by memory chip makers is called spacer double patterning. A 45 nanometer pattern is exposed onto the wafer, after which that structure is doubled by cleverly adding thinner lines alongside the originals and getting rid of the originals later, leading to 22 nanometer lines. Additional lithographic exposure steps are then needed to finalize the pattern. Up to 2012 at least, double patterning will keep Moore's law alive. It will lead to chips with billions of transistors. Flash memory sticks from manufacturers like SanDisk will have a capacity of 64 gigabytes and more.
Soon we have to print 32 nanometer small lines. And we have to do this with a precision of plus or minus 1 nanometer. And we have to place the images on top of each other within an accuracy of 2 nanometers. If one keep in mind that 1 nanometer is only 4 silicon atoms wide, we know that this is an incredible challenge we are faced with. On top of this, we have to print billions of these lines per second. And we have to do this day in, day out, without making any mistakes.
Double patterning means 2 times the number of lithography steps. These extra steps take time and thereby increase production costs. To make sure that lithography machines will continue to offer more value, they need to become faster.
ASML latest machine, the TwinScan 1950, prints smaller lines and more wafers per hour. Thus it offers 25% higher productivity and thus value than its predecessor. By doing so, it paves the way for double patterning.
Future machines will need to meet even more demanding specifications. To achieve this, engineers are looking beyond the machine itself. Computational lithography and metrology will also be developed to enable smaller lines, measured by counting single atoms, and enabling even more powerful electronic gadgets.